Who do you think has the bigger brain? Aladdin or Jasmine? That's simple. Clearly the answer is...
Down with DCE.
Yeah, you know me.
You down with DCE?
Yeah, you know me.
You down with DCE?
Yeah, you know me.
Who's down with DCE?
Okay, let me quickly add in, when I say bigger brain, I do actually mean brain size. Who has the brain with a larger cortical surface area? So if you were to take the cortex, the outer layer of the brain, smooth it out with grandma's rolling pin, and then measure its surface area, who would have the bigger brain? Aladdin or Jasmine? Did you pick a candidate? Okay, now hang on to your answer for a minute. What I'm most curious about is the why behind who you selected. If you said Aladdin, why do you think he has a bigger brain? If you selected Jasmine, what is it about Jasmine that would lead to her having a bigger brain? Most students I have had will lean on experiences and how that could potentially impact brain size. Aladdin is a quote-unquote street rat. Orphaned at a young age, he's learned how to survive on the streets of Agrabah, oftentimes turning to stealing. Jasmine is a princess, daughter of the Sultan of Agrabah, who lives a lavish life in a castle. Indeed, experiences can play a pivotal role, but I selected Aladdin and Jasmine as the example in this video to specifically draw a contrast of wealth. And yes, of course, different experiences can shadow various levels of wealth. Socioeconomic status, SES, is composed of three factors: income, education level, and occupational status. This video will present the findings from a study that explored the relationship between SES and cortical brain surface area. Results showed that parental education and family income were both associated with children's total brain surface area. Any increase in parental education, even just one extra year of high school or college, was associated with an increase in surface area. Family income was significantly associated with total brain cortical surface area. While the association was widespread, the association was strongest in key brain areas, shown in yellow. In the temporal lobe, insula, and inferior frontal gyrus, and the right occipital and medial prefrontal cortex, brain regions that had been previously linked with various language and executive functions. This highlights, at the brain level, what behavioral research has found for many years. We have known that income is related to cognitive outcomes, but this study documents that income is also related to the actual surface area of brain regions that support cognitive and executive function abilities. Importantly, the association between income and brain surface area was greatest for families at the lowest income levels. This makes sense when you consider the challenges a family with children may face with low income, such as $30,000 a year, or even $50,000 a year. Making a few $1,000s more a year could mean a lot to these families. An extra $10,000 for a family that makes between $100,000 to $150,000 a year will most likely not be life-changing. But an extra $10,000 for a family only making $30,000 a year will most likely have a significant impact. As you can see in the graph on the screen, the black line represents this disproportionate relationship between income and brain surface area. The black line is steepest at the left of the graph, where family income is the lowest. As family income increases, the black line quickly straightens out after about $100,000 to $150,000. The black line is nearly perfectly parallel to the x-axis. The steepest gradient occurs under $100,000, primarily under $50,000. This graph suggests that even relatively small differences in the annual income levels of families earning the least amount of income is associated with relatively large differences in brain surface area. In comparison, for families with higher incomes, small differences in annual income levels were associated with relatively small differences in surface area of the brain. This is really important, so let me use one more example to make it even more clear. Let's say there are two children, Jasmine and Aladdin. Jasmine is being raised in a family where their total income is $60,000 a year. Aladdin's family earns $50,000 a year. Even though there is only a $10,000 difference between the two families, this relatively small income difference is likely to be associated with a relatively large difference in the brain surface area of the two children. Now, consider if their families made more money. Let's say Aladdin's family earns $160,000 a year and Jasmine's family earns $170,000 a year. Again, just as in the previous scenario, the income difference between the two families is only $10,000. However, this research suggests that the $10,000 difference in this scenario will not impact the surface areas to the same degree. Even though there is only a $10,000 difference between the two families, this relatively small income difference is likely to be associated with a relatively small difference in the brain surface area of the two children. Another important finding from this study was that the association between income and cortical surface area did not depend on age or race ethnicity. Other research has demonstrated that income can impact brain development early on, even before a child is 2 years of age. The income surface area relationship held up across various races and ethnicities. This highlights just how impactful income can be for influencing brain development. The impact begins early, and all races, ethnicities are potentially equally vulnerable. Additionally, it should be emphasized that SES should not be used as a predictor of brain surface area. Low SES does not necessarily directly lead to smaller cortical surface area. The key factors that may be driving the statistical association in this research are not necessarily restricted to a family's SES. For example, research has associated SES with the amount of words children are exposed to. However, research has also found that while there is a relationship between SES and language quantity, some families of low SES talk a lot, and some families of high SES do not talk as much. So the point is, the study documents a relationship between SES and cortical surface area, but we should be cautious to draw this as the conclusion for all children based on SES. The findings from this study suggest that a family's SES is positively correlated with a child's cortical brain surface area, and this relationship is greatest for families earning incomes under $100,000 per year. What does this mean for our Disney characters in Agrabah? Jasmine may have a bigger brain than Aladdin if we use family wealth as a key difference between them.
Made you look.